Hello, welcome back to BlenderSushi Live Noding. In this episode, we're gonna take a look at one function of curve in Blender. That's where you can actually scale the point and radius and also do the tilting. It's not something that's quite obvious, but I'm gonna show you real quick. So this is one of the kind of like a result that I made using Sverchok and also Blender ability to control the radius and tilt of curve. So you can see that's actually what's happening here is actually an array of objects and then being deformed by curve, where the curve itself is kind of being controlled in terms of radius and tilt using Sverchok. So it's quite unusual, but this is very useful. I'm gonna show you real quick. So if you're doing it manually, for example, you have the monkey head and then you create an array. Instead of doing it that way, we can also do it in the Z direction. So let's make like a 10 monkey head. Okay, and then you have, let's have like a curve. I'm gonna use Bezier Curve. By default, Bezier Curve just looks like this, looks like a function. I don't actually quite like that. I like to kind of zero out this thing. In fact, I'm just gonna make this curve, turn it into polygon curve. So it's a simpler curve. Everything is linear and straight, doesn't have any curve. Now with this guy, I'm going to use the curve to deform the monkey. So I'm gonna add a curve modifier and select the curve, and instead of deforming it in X directions, we're gonna deform it in Z direction. So now we have the monkey head kind of deformed that way, following the curve. Now I think we can also make it to fit the curve and stuff. Yeah, something like this can be super useful. There's these relations of array and curve modifier that's I really like, and this is something that I want to emulate in Sverchok at some point, and then I kind of want to expand on that. Array and curve is really powerful. Array modifier, of course, it's kind of limited, where you can't have like a different array objects in the middle. But if you are using like Sverchok, you can easily change that. What's nice about array is that we have the start cap and end caps, kind of like the head and the tail that you can plug in anytime. That's something that we're gonna look in another live noding. But for now, let's focus on the curve. Okay, so back to the curve, and then I go to edit mode. I can kind of extend the curve, and this is really powerful. It's something that's really I kind of emulating in Sverchok many times through multiple live nodings. But there's one thing interesting with the curve, that's you can control the spline scale, the spline radius and tilt. This they call it tilt and string pattern. String pattern will control the radius basically. I think the shortcut is Alt A, actually not Alt A, Alt S. Okay, Alt S, S for scale. So you can kind of have this control over the scaling of the radius. So I can make the radius like super small there, and make it also super small here. And the cool thing about curve in Blender is if you select 2 points, you can kind of, okay, I want to simplify that, and you have the middle curve, and with the middle curve you can control the scaling. I think this is really powerful. And also you have control over the tilting. The tilt is here, it's a Control T. So Control T and Alt S, it's written there, shortcut. And you see, you can also tilt. just in case you need to tilt it. I think many Blender artists already know this. I'm still kind of figure this thing out, and I just realized, okay, you can apparently use the scale and tilting, but can we control that procedurally? Now that's a question that's I want to answer using Sverchok. You can of course using Python to do this, but yeah, let's see. Sverchok tilt and string pattern. So actually I just call it tilt and radius because that's really what it is. So I have the curve, right, and then I'm gonna use Sverchok, and I'm going to use the object ID thing. Object ID get will get everything. If I select like the curve here, it's gonna get all the curve, but we want to specifically get that one curve. So I'm gonna get the selection. This is our curve, okay, Bezier curve, and we have this object output right here. Now object get, object set, object ID set actually can this thing will allow you to access any data blocks inside the curve. In our case, it's the radius and the tilt. So I'm gonna plug in the objects there, and then I'm gonna use the stethoscope and see if we can get any kind of output. Currently, it's looking at the delta locations. We don't want that. We want to actually access the spline data, the point, if I'm not wrong. And it's not the normal point, we need the active point, if I'm not wrong. So instead of guessing, I'm gonna use the Python console and really gonna dig into that curve. Okay, BPY object, BPY data, I think object, and we have the Bezier curve. Okay, that's the curve data that we want. So I'm gonna put this into my own variable. So I'm gonna call it my curve data spline let me think. My curve, and then we have spline data. Okay, my curve. We need to access the data, and the data should be the splines, and the spline should have like an active points. This is me kind of guessing, and if I'm not wrong, there's this radius. There's radius interpolations and there's a tilt interpolations that we can change, although that's really not what we want. I gotta have a quick look at my other setup. Data splines active points radius. Data spline active point radius. Okay, apparently it was correct. We almost there, but with the points we need to go and then select the points and actually accessing each and every point. So see, we don't know how many points we have, but basically we can check the radius that way. So for our objects here, I'm gonna look here. Our object is BPY data curves Bezier curve, and the data we want to access is the my curve data spline active points. I'm gonna copy that, paste it here. Something like this, but then okay, we access that particular points, but we don't want that particular points, but we want all the points. And now here, this guy now accessing all the points. We don't want to access the points, we want to access the radius. Okay, that's the whole radius there. And then we can see the tilt. This is the value of the tilt. if I make like any changes to the curve, like make this maybe it's a Control S, it's Alt S, Alt S. See, I'm changing the radius value. If I update it, this guy 6.17025. That's the one that I just did. Okay, so we can access the value, yeah, of the tilt and the radius. Now what can we do with it? Of course, Sverchok can control all the value here. If I say like, okay, I want just a random number generated, okay? Be careful with this, it might actually crash because it's kind of sensitive sometimes. But if you provide the right number of value here, how many? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, 17 value generate a random value between 0.212 and 1. So this data looks like this. Okay, if we plug that into our radius, this guy is gonna change. See, that's really cool because now we can work in the object level, and then we can change this data basically using Sverchok. Okay, yeah, that's what I was talking about. This thing is very, very sensitive. You better save quite often. Usually my workflow is I tend to bake for this kind of thing. I tend to bake it at some point. So once you bake it, everything is good. But maybe this is something that's Blender wasn't. Blender kind of surprised that we can kind of access the data right away. I think that's kind of what's going on. See, now it's kind of working fine. It didn't crash. Every now and then there's few steps that kind of causing Blender to get shocked and then it crashes itself. But once everything is good, we can have control over the radius. So let me summarize again. Here I get the objects, which is our Bezier curve, and we are accessing this data.splines active. Active is the points that we can edit. It's not the points that kind of generating stuff. So in this case, Sverchok act like a really powerful drivers. We can also control the tilt. With the tilt, if I want to make the monkey head kind of spiraling, I can use range. Let's try range floats, I believe. We can plug into that guy, and then the count should be 17. Save it, and then now I can control the tilting using this value. This is kind of I'm not sure if it's in degree or what other. With monkey head, it's not so obvious. Maybe I should just use like a cube. Okay, have a cube, and then I go to edit mode, and then this cube will grow up. I'm gonna scale it in X, make it a bit smaller, and then instead of monkey head, I'm gonna change it into this cube. Actually, into the box. So this is the monkey head that I can just delete. I'm gonna use this guy, create an array again once, just like before. Relative offset or constant offset, we're gonna see the difference real soon. We're gonna use the curve modifier, select our curve, make sure it's in the Z axis. Okay, now increase the number of box. At the moment we cannot really see what's going on because they're kind of close together, but now I'm scaling this guy and we can see it's actually kind of neat, very neat. Fixed count. Okay, let's increase the count. This is super interesting actually. Yeah, in theory we can generate something like this inside Sverchok as well. Maybe not as simple. This is something that I kind of juggling between Blender normal workflow and then Blender kind of like a nodes hack using Sverchok or animation nodes. This is yeah, if we are we are working this way, it's really makes more sense for beginner. If you are more advanced user and more technical, you can use everything. You can generate this all this array stuff, like a modifier stuff inside Sverchok. Yeah, so we have control over the tilting. Like I said, you can change this everything procedural. Imagine having to do this manually. You kind of need to tilt it. It's not something fun to do if you're doing it manually, but since this is procedural, I think it's really fun. Now you can still go inside the curve and hey, adjust the curve. This is like so fun, and it's very practical. And then you have the spiraling thing happening, and then you can still have control over it, and it just crashes again. Like I said, I don't know what's going on there. Maybe it's a bug in Blender, or this is something unusual that Blender itself is not familiar with, that you can actually change the radius and the tilting on the fly. But I already told you that this gonna crash sometimes. Now this should be working fine again. That's the tilt. Just play around with it. Radius, okay. Random number is fine, but maybe you want to have something that's less random, like vector fractal, or maybe vector noise. Just output a scalar, because we need just a scalar value, not a vector value. Let's make like, see, okay, with the vector noise and vector fractal, we need a kind of vertices input, and for that I tend to use line and then give it the number of points, in this case 17 points, I know, and then plug that into vertices and plug in the noise into this guy, update it. Okay, now it's updating, and then by some kind of magic we have the thing kind of working. There is something with the interpolation here. If you notice, the interpolation is linear. We can definitely change that. You saw that earlier. You can change it using a Python script. We're not gonna worry about that for now. We can multiply the vector noise using our own value, or add our own value. It's also possible. Now, every now and then, it doesn't seem to be updating, and we need to just scrub. Maybe it's not factorized here. Or maybe it's getting like a negative value. I'm gonna use math and then use absolute here and update it. Hopefully things still gonna work. Okay, seems to be working. What's the value here, really? Maybe I need to join it or something. Seems like it's working, but it's not liking something. Okay, now it's working fine. Line. See, changing the stepping of the line, kind of okay. But if we want like this is line going into the vector noise. If you want to move the noise kind of slowly, we can use vector. We can use move, I think, move nodes, and just move the vector in one axis. Now we have, you see the motion there, down there. That's really kind of nice thing about it. Back to this guy, I think we can really just use our own value. You see, this is addition, and then on top of that we have the noise, which is this guy. The noise, we can control the noise using frame. control the speed. And play oops, playback, alt A. Now we have kind of like living creature. It's almost like a, what do you call it, spiral worm, or like a ribbon kind of worm, or it can be like a DNA pattern. Let's see, fit the curve. Bezier curve doesn't seem to fit the length. So anyway, just play around with that. And there's a constant offset here that we can also use. Slightly different result. How many points? I think, oh, I know why. Sometimes it's updating and sometimes not. That's because of the number of the points here. It was changing at some point. I don't know. Anyway, we get this now. We have the control over the tilt still, okay, and then we have control over the radius. We have slight noise value going in. We can, instead of using vector noise, remember we can also use vector fractal. It's totally up to you. Just do it like this, should work. Fractal, standard Berlin, they're similar in this case. Can change the noise value, like Voronoi, maybe cell noise. Cell noise give you like kind of this, like a stepping, snapping kind of motion. Very unusual. Okay, so if you really want, you can also use a random value on top of this. So all this value coming in together, and then you can do more, like any kind of a number pattern that you can think of. Just plug it in, just pass it into Sverchok, and it will kind of update. And if you want to see the value, check in the radius. See, yeah, this is a, oh, it doesn't like this. Okay, this has input and output. That's why it's kind of complaining. Is this gonna be the output or gonna be the input? I know why. That's why. Don't do it like this. Do it this way. This is better. So this one gonna give output. This one's gonna take input. So now everything is good. I learned something again. So remember, if you have like the output, don't plug in the input. It's gonna be weird. Now everything's good. If you really want, you can bake this out. Like I said, baking is a good idea with Sverchok before rendering. Otherwise, you don't know what's going on. Normally it's fine, but let's create a baking real quick. Displace, zero it out. Oops. File, export, Alembic, 100 frame, selected object only, export Alembic. So this is a baking process, okay. And then once it's baked, you just open a new file, fresh file, and then file, import. ABC Alembic, get our bake object. So this guy, see, still working. 100 frames, playback. Still using the cell. You can randomize this. You have this bake object, right? You wanna do something crazy? Okay, you can do that. Sverchok, random vector. Show you something a bit crazy here. Okay, this thing generates a lot of points. And the mesh viewer will generate a real object, and because this is now a real object, you can parent this to that guy, I believe, and then just simply use a blender duplicate face. I think duplicate is actually, this is actually working. It's just the rotations. Scale it. Yeah, see that that's a lot of objects, although they are not, they are kind of rotated in the same way. Need to be able to control this, so the best way is to generate like triangles, and then I think you can just generate like a plane, and then you assign a random rotations to this, and then you end up with something that's complicated. Anyway, this is just an extra thing. I have another live noding that already talked about this duplications. Sverchok kind of generating all the points, and then Blender dupli generates the result. Oh yeah, so array, curve radius, and tilt. You can control it all using Sverchok. You can drive any attributes that kind of accessible using Sverchok. That's my main point. Okay, thanks again for tuning in to this live noding video. Any comments, suggestions, just let me know down below. I'll see you in the next video. Thank you. Bye.